one can separate the metal from the organics using strong acid and then reassemble those using zero discharge methods and using water as a solvent. So the very chemistry that we discovered is not just about making the frameworks, which is exciting, and their applications, but also it allows this variability and this flexibility allows us to regenerate the material with zero discharge of any contaminants. So I'm very, very happy actually you asked that question because not many have been discussing this out there. Yeah.
Thank you. Jonathan Allen, would you like to unmute yourself and ask your question? Jonathan's asked me to read the question. What do you think the biggest impacts of MOFs might be, and how might they look different in 30 to 50 years?
I think one of the things that will stay past my life is the fact that if you can think it, you can make it. Okay, if you can think up a material that you want, whether you're a startup or a professor or an emerging student trying to learn chemistry, you can actually go to the lab and make it. And it sounds trivial, but this is not so easy in chemistry. Sometimes you think up molecules, materials, and you go to the lab and you find, well, it doesn't really work the way you thought it would work. But here, with very few attempts, and now with the aid of AI, if you can think it, you can make it. And that is really powerful. And needless to say, you're building these things from nature's building blocks, minerals and organics. And so I would say that that's quite powerful. I think the future, given the variability and this precision with which these materials can be designed, I think you're going to make MOFs that operate like DNA, operate like biological systems, where a sequence of molecules arranged in a specific spatial orientation within the MOF code for specific properties. Okay, and I think that that's the future.
Thank you. I'm curious also, thinking towards the future, what role do you think AI and data science will play in sort of helping to design new chemistry and new applications for MOFs?
Well, for example, we have already demonstrated in our lab as part of a new institute, AI for Materials Institute, BIDMAP, Baker Institute of Digital Materials for the Planet, BIDMAP. BIDMAP, our work there, we've shown that, okay, it's easy to make a MOF, right? But it's not so easy to make it in crystalline form, in that perfect form, like a jewel, right? Which sometimes you do need to identify the constituents of the material on the atomic and molecular level and understand how it's put together, right? That takes time. That takes a lot of trial and error. Every chemist, if you ask them what is the most difficult thing to do, they'll tell you we spend 80% of our time trying to crystallize our compounds. Well, AI is helping us speed up that process. Things that MOFs that would take a year or 2 years to crystallize, we're doing that within a course of weeks, and now even days. Okay, using LLMs and using AI tools. So AI, I think, is the future. I think it's intricately connected with chemistry, with MOF chemistry as well, and it's a huge direction that will enable us to ask deeper questions, make faster discoveries, and reach society much faster than we've ever done.
Thank you. Question from Bob Service. Can you share your thoughts on the state of American science and the country's willingness to be open to people and scientists from around the world?
Yeah, I mean, science is a language that allows all people to talk to each other. That's one of the few languages where we all understand chemical formulas, whether we're Japanese, Australians, Koreans, Chinese, or American. A chemical formula is universal. And The lingo that goes with that is also universal. So science allows us to talk to each other, and I don't think you can stop that. I think that that's something that will continue to be important, and enlightened societies will encourage it. So I am optimistic that we will continue to exchange throughout history scholars from even countries that you would think were adversarial. They scholars can be exchanged and learn from other scholars in other countries, and this is how knowledge was spread from one region of the globe to other regions of the globe, is through exchange of scholars and through the mentoring system that we do so well in the US, mentoring students. So, Bob, I'm not sure if I answered fully your question. I'd love, if I didn't, I'd love a follow up.
Thank you. We have another question also about how you've benefited from federal grants and funding in your work.
Well, my very first grant was an NSF grant. Okay. And I tried, it was very competitive, it was very hard to get. I didn't get it until the third trial. Okay. So, but I did get it in my second year as an assistant professor, as an independent researcher, and it gave me an opportunity to do more to do this research, to actually get the first success that led to the Nobel Prize. That was an NSF, a National Science Foundation grant. Um, then this was followed by a DOE grant on using these materials for separation, and these agencies go through. We went through a rigorous refereeing process, and if you didn't get almost perfect scores, you really had to get perfect score to be funded. And so this allowed us to challenged us to not just do rigorous science, but also creative science. And they were absolutely key in enabling me to go off in my own direction, away from whatever was happening in chemistry in the mainstream. I wanted to do something completely different. And these grants allowed me to do it. So I really encourage us as a society to apportion some of our scientific funding to allow people to think outside the box and to encourage that. So federal grants played a major role in the initial discoveries that led to this amazing field.
Thank you. I think just a couple more questions. First, you talked a little bit about public universities and just public schools in general. Could you talk a little bit more about the role that UC Berkeley played in your work?
Well, UC Berkeley, I call it the nirvana of science. I mean, when I was on the market as a young scholar looking for an independent position, for a professor position, I wanted to come to Berkeley. I interviewed at Berkeley, but at the time, I don't think I did a good job at the interview. Okay, when I was young. Okay, I was very young at the time. But since then, my aspiration was to get to Berkeley, because Berkeley was the place, the dream place for a serious scientist to be. And it proved to be the case. You have incredible colleagues, incredible facilities, and as I said, incredible administrators that leave us to our own devices to discover and fail and fail and succeed and build fields without interfering in the inner working of the research. So I really I still think after now almost 12 years being at Berkeley that it's a great place, and I don't see myself going anywhere else, because I have arrived at my ideal place.
Thank you. We're getting a few more questions in the chat. So First off, Maggie Donaldson with AFP, would you like to unmute yourself and ask your question?
Yeah, hi, and congratulations. I just wonder if you could expand a little bit on your upbringing and your experience as an immigrant to the United States and sort of what this recognition means to you within that context.
Well, I mean, I'm quite emotional to see my refugee parents spend every minute of their time dedicated to their kids and to their kids' education because they saw that as a way to lift themselves and the kids out of um, challenging situations. I mean, that takes incredible commitment, and I was not short of love. I would say that they were. We didn't have a lot of the conveniences that many others do, but we had a lot of love and a lot of care. I think early on, I was a very independent child, and maybe my chancellor can understand my behavior sometimes. I said, I said, I said to my parents that at a very early age, I think it was third grade, that I want to be left alone. I will do well in school, and I want to be left alone to do whatever I want. And I think that they cared enough about me to let me experiment and play with things and carry out my own on my own. But I was a diligent child. I grew up in a very large, rowdy family, but I was a very quiet child. I was the one that would be in a corner, sitting there doing his studies and writing his lessons and so on. Um, but I think the key was that my father saw opportunity in sending me off to the U.S. and much to my objection, he insisted that I do that. I wanted to stay in Jordan with my family and finish college there and work there. But he saw that there's potential elsewhere and did not hesitate to send me off um, on a KLM flight to the U.S. So um, I, I I guess in terms of my childhood, I think my break came when I really saw molecules and I fell in love with them, even before I knew they were molecules. I think that's really important to point out is that we don't need to be as methodical and as rigorous in our planning on what we are going to do at such an early age. That you have to just figure out what is drawing you to what you're doing, what your interest is. It doesn't have to be deeply intellectual. It could be just a raw interest or raw uh, passion to something. And I was fortunate that I met the molecules early in my life.
Thank you. Mega Satyaranana, would you like to unmute yourself and ask your follow-up?
Um, so what is your advice to young scientists, given our current political and funding atmosphere, given our, current situation in which so much of science and evidence is eschewed in favor of specific political and ideological concepts? Is science still a career people should pursue in the US? What is the secret to being successful right now, if this is where you're starting?
You can't solve society's problems without science. You need science. Um, that lead to building industries and with various things, various sides. Sides. Okay, just try to create something completely new and not to be a follower. And then somehow I was fortunate to join the group of Walter Klemper at the University of Illinois as a graduate student, and there again, they're the same lesson, except now we're talking about molecules. It says, well, I want you to make something that nobody has made before. Challenge me to go beyond what is out there. And so one is, my father perhaps taught me what ethics are, and how to be a good person, and so on and so forth. But my PhD advisor taught me, basically sculpted my brain on how to be a rigorous scientist, but also to think beyond what is already out there. So if it wasn't novel, it wasn't worth doing with these two characters in my who were in my life. So I would say that was quite um, uh, important. But then you have to really understand that it's very risky. It requires hard work. It's full of failure, as all great things are, and you just have to sustain and believe in the power of the experiment, right? That would be my advice to the young people, is to believe in the power of the experiment. When you experiment, when you do the experiment, you open the door to potentially make big discoveries. If you don't do the experiment, then nothing's going to happen. So, yeah.
Thank you. Okay, I think we'll have one or two more questions and then wrap up. First, I see Kathleen Moore, you have your hand raised. Would you like to unmute yourself and ask a question? All right, not hearing from Kathleen. I'll go ahead and ask, what are your plans for the rest of the day? How are you going to celebrate?
Well, I'm in a conference, and so tonight they have a dinner. I think we're going to celebrate there, and discuss what we're going to do the following day, where I lead a discussion about complexity within order. That's basically there's nothing else planned beyond that. The usual. Obviously, I have to reply to some of the congratulatory emails. Yeah.
I think, Kara, if that's the last question, I think we'll wrap this up. Thank you for all the great questions, and thank you, Professor Yaghi, and congratulations again on winning the Nobel Prize today. Remember, to the reporters, that in the chat are links to folders and Google Drive that have images, and we'll eventually have a video of this press conference. But have a great day, Professor Yaghi. Enjoy the rest of your day and the accolades that are going to come your way, and toast yourself today as well.
Okay, thanks everybody. Thank you. Appreciate your warm congratulations. Yeah, bye-bye.